Good morning, students. Now we are going to discuss about open loop configuration and closed loop configuration of opamp. So in open loop configuration of the opamp, the term open loop indicates that no connection exists between the input and output terminals. If you see in this diagram, there is no connection between the input and the output terminal. That is, the output signal is not fed back to the input signal. Therefore, the output has no effect on the input. In open loop gain, the op-amp functions as a high gain amplifier, and hence the open loop voltage gain is defined as the ratio of output voltage to the input voltage with no feedback. It is given by AOL. AOL stands for open loop gain is equal to output voltage by input voltage Vi. Next, closed loop configuration of op-amp. Closed loop configuration is possible with the help of feedback, whereas open loop no feedback, but in closed loop there is feedback. This feedback allows some part of the output to fed back to the input terminals. In linear application, op-amp is always used with negative feedback. Okay, because with the positive feedback, it leads to more oscillation. Hence, positive feedback are used only in oscillators, not in amplifiers. So, the negative feedback helps in controlling the gain. Otherwise, the op-amp will be out of range. So even for a small noise voltage at the input terminals, the output of the op-amp will be out of the linear range. Hence we are using only the negative feedback. This is the circuit for negative feedback. That is, some part of the output voltage is fed back to the inverting input terminal through the feedback resistor RF. Thus the open loop voltage gain, closed loop voltage gain ACL is the voltage gain of op-amp when the feedback path is closed. The closed loop voltage gain ACL is determined by the external components such as resistors, capacitors, and by controlling them accurately we can control the closed loop gain. Due to feedback resistance, there is reduction in gain. Okay, in the negative feedback, because of the feedback resistance, there is reduction in gain. In terms of open loop voltage gain AOL, the closed loop voltage gain ACL is given by the relation ACL is equal to AOL divided by 1 plus AOL into beta, where beta is the feedback factor. I have explained this positive feedback and negative feedback in the other video. You can go through it for more information about the feedback concepts. Now, concept of virtual ground. As the name indicates, this ground is virtual, not real. So for some purposes we can consider it as equivalent to ground. In op-amp, the term virtual ground means the voltage at a particular node is almost equal to ground voltage. So if you see this diagram, this is the virtual ground. So here the voltage is 0 voltage, which is almost equal to ground voltage. It is not physically grounded. Okay, it is not physically or mechanically grounded. Hence we are calling it as virtual ground, because in this mode we have the voltage equal to ground voltage. So why we are calling it as virtual ground, or why the voltage at the virtual ground is 0? The reason is, Since the gain is infinity for an ideal op-amp, so we want gain A to be infinite. What is gain formula? Output voltage by input voltage. So here VO by VI minus VG. Why VG? Because VG, the voltage at the, if you see this diagram, the voltage at VG, they also come along with the input terminal. So it comes under input voltage. So gain A is equal to VO by VI minus VG. So here VO, that is equal to VO divided by VI is 0 volts minus VG. So any number divided by 0 is infinite. So if I want infinity, VG should be 0. Therefore A is equal to VO divided by 0 minus 0, that is equal to infinite. Okay. So we are calling that node as virtual ground, whose value is equivalent to the ground voltage. Hence, even though VG is not connected to ground physically by a wire, its potential is 0. This is called virtual ground. And this concept of virtual ground is possible only in inverting amplifier, that is with the negative feedback. Because I said only negative feedback is used in amplifiers, whereas positive feedback we use in oscillators. Next heading, gain, bandwidth product and frequency response. Although op-amps have a very high gain, it has limited bandwidth because the level of the gain starts to fall even at low frequencies. It was found that the gain has fallen by 3 decibel even at the frequency of a few hertz. And beyond this frequency, the gain falls at a rate of minus 20 decibel per decade. What is decade? It is a 10-fold increase in frequency. That is, the gain decreases by a factor of 10, but the bandwidth increases by a factor of 10. Okay. Thus, the gain of the op-amp is frequency dependent, and the product of gain and bandwidth is a constant and called gain bandwidth product. It is designated as GBWP, that is gain bandwidth product, or we can also express as GBW or GBP or GB. All are same. If you see this graph, the gain has fallen at a rate of minus 3 decibel. Okay, beyond this frequency, the gain has fallen at the rate of minus 20 decibel per decade. So in this graph of voltage gain in decibel versus frequency in hertz, we can see the gain has started to fall at minus 3 decibel, and beyond this frequency we have the fall rate of minus 20 decibel per decade. That's all about open loop gain, closed loop gain, virtual ground and gain bandwidth product. Hope you all understood. Thank you.